I love the summertime. Smell that fresh air. Summer is such a great season for being outdoors, exploring nature, discovering its mysteries. But it's also a great time for water balloons. I have a great idea.
Hey! You! Reach for the sky.
Whoa, that was close. My arms just couldn't throw it far at all. Gonna have to think of another way. Maybe with a little bit of science and an old-fashioned tool, we can find a way of leveraging our way at getting back at him. Levers are one of mankind's oldest inventions. Think of them as a teeter-totter. A teeter-totter is simply a lever for human-sized objects. Now, a lever consists of two parts, the actual lever or beam itself and a fulcrum. And the way that these two parts work in concert with one another is that they take a force applied at one end of the fulcrum or lever like this and actually change that direction as sort of a force multiplier that will send an object flying through the air. When you're doing an experiment, you only want to work with one variable at a time. So for this one, we are just working with changing up the length of the levers while keeping the fulcrum in place. If you are following along at home, you're going to need a few objects to help you out on doing this experiment. First off, a nice sturdy object to serve as your fulcrum. You're also going to want 3 levers of different lengths to see just how far each one will throw a water balloon. A measuring tape that's going to measure just how far those water balloons are flying, and a notebook to record your measurements. And let's not forget the water balloons! Remember, get permission from your parents for doing this before doing this experiment. So, we're going to have 3 different levers. Our small lever, our medium length lever, as well as a long lever. And then we're going to have 3 separate trials of each lever. Trial 1, 2, and 3. Draw some lines. And when we are all said and done, we have ourselves a table. Results now and see which of our levers did the best job. Looking at our first trial, which of our 3 levers, the short, medium, or long one, threw the balloon the furthest? Well, looks like we can safely conclude that our short lever threw the balloon a good distance, 375 inches. Going on to our second trial, which of our 3 levers, short, middle, or long, threw the balloon the furthest? Well, based off of our data here, looks like the short lever did it again. 286 inches. Now for our final trial, trial 3, which of our three levers threw the balloon the furthest? Well, I think we have a little bit of a surprise here. Our middle lever did the best job that round. So now, looking at our data, which of our three levers threw the balloon the furthest the most times? Our small lever did it 2 times. Our middle lever won 1 time. And our long lever didn't win once. So based off of our criteria here, our short lever seems to be the one that throws the balloons the furthest. Let's see if this gives us the upper hand. Woo! It did it! I hope you all have a safe and fun summer with all your games. And if you can, try to add a little bit of science to it to make it even more fun. And until next time, curious minds, stay curious. Look at this. It threw the balloon back towards me. That's not a quality in a lever that I want. However, when we look at our long lever, we do see that while it's not doing the best job out of the 3, it is doing a fairly good job being consistent from one throw to the next. Maybe that's something that I should be looking for out of a quality lever.